Hello everyone. Today we are going to discuss about the DFA problem 3, design DFA with AB as substring. Let's start the more in detail understanding of designing DFA with AB as sub.
Hello everyone. Today we are going to discuss about designing the deterministic finite automata which accepts AB as substring. Okay, so the question says we have to design a deterministic finite automata which accepts AB as a substring. Substring means this is a string, substring over an alphabet sigma equals to a comma b. So we have to design a deterministic finite automata which accepts AB as substring over an alphabet sigma equals to a comma b. So sigma equals to a comma b means we have to design the deterministic finite automata in such a way that it should accept a string contains only the input symbols a and b. Okay, but there is a logic in this particular question that the string should have AB as a substring. Means before AB it can have any number of A's or B's, and after AB it can have any number of A's and B's. Okay, so first we will assume some sample string for this particular question. So AB, before AB and after AB it can have 0 symbols also. So the basic string what we can get is AB. Then before AB we can have any number of A's or B's, and after AB also we can have any number of A's or B's. So AB, before we can have 0 followed by any number of A's, or before AB we can have any number of A's or B's. So generally we will write like this, the regular expression as a plus b whole star AB and a plus b whole star. Means it can be empty or this can be empty, but AB should be a substring. So the sample strings what we can take are AB, before AB we can have A, finally we have AB as substring. And after AB we can have any number of A's or B's. It can be B, or it can be AB, or it can be ABA, or it can be AAB. So finally we have AB as substring in our given sample strings. So the basic string what we can get is AB. Before this AB we can have any number of A's or B's. After AB also we can have any number of A's or B's. So it is left to us to choose that particular string and try to design the finite automata. Okay. So now what we will do? We will try to design a finite automata for the given regular language. So let's start. So we have AB followed by any number of A's and B's, or before AB also we can have any number of A's or B's. Okay, now we will try to design the finite automata. So start from the initial state, that is Q naught. Q naught on reading input symbol A. The sample string at what we have taken, that is AB. So Q naught on reading input symbol A. It is going to the state Q1. Q1 on reading input symbol B. Moving to the state Q2. This is the basic string, means this string should be accepted. So AB will be accepted when you make this as the final state. Okay. So the basic string what we got is AB. So for AB try to design a finite automata for that. So Q0 on reading input symbol A going to Q1, Q1 on reading input symbol B going to Q2. So the string AB is accepted. So before AB, we can have any number of A's or B's, right? This is the logic. Before AB, we can have any number of A's or B's. So Q0 is having a transition with A, but it doesn't have a transition with B according to the DFA definition. So Q0 is having only transition with A. You can make a transition with B with self loop. Means before AB, we can have any number of B's. So that is accepted. We can have before AB, we can have any number of B's. B, B, B like that according to this. So we can put a self loop to Q0 because according to DFA also, Q0 should have a transition with A and B. With B, we have put self loop. Similarly, Q1. Q1 is having a transition with B. It should have a transition with A also. If I put A here, then we can have any number of A's. Totally, we should have AB, right? So we can put a self loop here. A. So if I take a strings like A, B, then this will be accepted. A, any number of A's, B, ending with this one. Hence it is accepted. If you want to take single AB, this is accepted. Two ABs, one A, two AB, this is accepted. So hence we can put a loop. Now Q0 is having a transition with A and B. Q1 is having transition with A and B. Now Q2. After AB, we can have any number of A's and B's. Right? After AB, we can have any number of A's and B's. Hence, I can put a transition over Q2 self loop with A and B. Suppose if you take A, if you take ABA, ABA, ABA is accepted. And again, if you take one more transition like AAB, right? AB followed by any number of A's. AB followed by any number of A's, AB followed by any number of A's is accepted. AB followed by any number of B's, AB followed by any number of B's are accepted. Similarly, AB followed by any number of A's or any number of B's also accepted. A, B followed by any number of A's or B's are accepted. Hence, this is done. Now, Q0 is having a transition with A and B. Q1 is having transition with A and B. And Q2 is also having a transition with A and B. Now, check one sample string whether the DFA what we have written is correct or not. Consider some string like A, B, A, B, A, B. Okay, this is the string. This should be accepted because it contains AB as substring. Whether it might be anything, but AB should be there. So if I take this A, B, sorry, A, B, A, B, A, B. So hence it is accepted. Okay. So if I want any number of A's followed by AB and followed by any number of B's, this string should be accepted because AB is a substring. A, any number of A's and finally one A followed by B and any number of B's. Hence, the DFA what we have written is correct because we should check with some sample strings. This can be done by using the transition function. So let's check transition function. Okay. Transition function means delta of star of Q0 over the strings A. Consider one sample string as A, B, A, B, A. So in this we have a substring AB. So hence this string should be accepted by our DFA. So we will write A, B, A, B, A. This is our string. So we will make delta of Q0 on A. So Q0 on A is Q1. So q1 after that is q naught on reading input symbol a going to q1. Now q1 on a b a b a. Similarly, delta of q1 on a, q1 on a is q1. So q1 ba ba. Next q1 on b, q1 on b is q2. q2 a b a. q2 on a is q2 on a is q2 only. q2 on b is q2. Next q2 on a is q2. Hence we are ending up with the final state. Once again I will repeat. See here, q naught on a. q naught on a is q1. So q1. q1 on a is q1 on a is q1 only. q1 on b is q2. q2 on a is q2. q2 on b is q2. q2. If you check here, q1 on a is q1, q1 on b is q2. q2 on b is q2. q2 on a is q2. q2 on a is q2. Hence it is ending up with the final state. Hence the DFA what we have written is correct, and strings accepted by this particular DFA is correct for the given question. So this is the finite automata, that is deterministic finite automata, which accepts AB as substring. Means before AB we can have any number of A's or B's, and after AB also we can have any number of A's and B's. Okay, so now first step is we should able to design a DFA, at least a finite automata, which accepts the basic string called AB. AB we have drawn, making Q2 as the final state. Next, according to definition of a DFA, all states of DFA should have a transition over input symbol A and B. So Q0 is having transition with A and it should have a transition with B. So B, we can have any number of B's before AB, so we have put a self loop. Done with Q0. Now with Q1. Q1 with B we have transition, with A we should see. Q1 we can make a transition with Q0, or we can make a transition to Q2 or to the self state. If I make a transition to this one, you may have any number of A's and B's followed by any number of A's and B's, like that it can have. Even if I put self loop also it works. So this is the transition for Q1 on A and B. Okay, you can either put to Q0 or to Q1. Both will work same. Okay, no need to worry about this. Now Q1 is having a transition with AB. Now Q2. After AB we can have any number of A's and B's. So we can put a self loop to Q2 with AB as a transitions. So this is the deterministic finite automata for string having AB as substring. Okay, hope you understood this designing DFA with this particular language. Thank you for listening to my session.